7-6 radical equations. This is the second lesson. Our target today is just to keep expanding your radical equation work. Now we're going to be solving equations where that involve more factoring, and it'll involve cube roots, and it will involve equations that have more than one radical in it. So the first equation we're going to work with has a cube on both a cube root in it, and I will again still want to isolate this cube root. So I will subtract 2 from both sides, and that's going to leave the cube root of x minus 5. And 1 minus 2 is -1. After I do that subtraction, I will cube both sides. Some of you might be thinking, well, how can you cube it? When we had this, Mr. Ollenberg said that this, the square root of 3x, is -6, but that was no solution. Well, the root on this is an even number, squared or 4s or 6s over here for a root. This would be no solution. When we do a odd numbered root, I can keep doing that because a negative times a negative times a negative. If I do 3 of those negatives in a row, my answer still will be negative. So that allows me to cube both sides here. So when I do that, I have the cubed root. I cubed this. I'll have x minus 5, -1 cubed. That is -1. And then if I add 5 to both sides, x equals 4. So now if I plug in 4 here, 4 minus 5, -1. The cube root of -1 is -1. -1 plus 2, 1. Well, 1 equals 1. So that solution works. All right, the next one. Next one has a square root in it. We have a binomial on the right side of the equation, and in the last set of problems you didn't have anything like this, so we're going to add 2. What do we do when we have binomial over here? I will square. This is a square root, so I square both sides. And when I square the left side of the equation, 9 plus x is remaining, equals, keep in mind that this over here is actually x plus 3 times x plus 3. All right, so then that is going to give me a perfect square trinomial that follows a pattern of squaring the first term, x squared, multiply the 2 terms of the binomial on the inside, so that's 3x, double it, gives me 6x. 3 squared then is 9. So there's my perfect square trinomial. I want to get everything equal to 0. When you're dealing with trinomials, you want your x squared to be positive. It just makes it easier to work with. So I'm going to bring the 9 over to the right side and the x over to the right side. There are no x squareds to combine a like term with, so I'll copy x squared down. I'm going to move the x. 6x minus x gives me a plus 5x. And when I go 9 minus 9, those cancel. So that leaves 0 equals x squared plus 5x. Now my factoring comes in. So say 0 equals, the common factor here is x. So that's x. What's remaining is x plus 5. And then I will say, okay, I have the 0 product property. So x is my single number out here. X either has to equal 0 or x plus 5 equals 0. Now, what do I have to do? Well, I have one factor. I already know one number, 0. Solve for this one. Subtract 5 from both sides, and x equals -5. Because it's a radical, test your answers in here. If I put in 0, 9 plus 0 is 9. So this is saying the square root of 9 equals 0 plus 3. And so that means, well, the square root of 9 is 3, and 0 plus 3 is also 3. So that's a true statement. So this works. Now I want to deal with the -5. So as I'm dealing with the -5, I have the square root of 9 plus -5, so that's the square root of 4. Does that equal -5 plus 3? Well, the square root of 4 is 2. Does 2 equal -2? False answer. So that means this one right here, x equals -5, we cannot use. We cannot use that because it gives us a false answer when we check it. So the only solution that works is x equals 0. Always check your solutions. Once in a while you'll find one that doesn't work. That's why I'm showing you this example, showing you that you will be working with some perfect square trinomials, and sometimes a solution won't work, so always test. Okay, last one here. We have the square root of 3x plus 1 plus the square root of 3x equals 2. I have two radicals. So, but I have to get only one radical on a side. So the first thing is to do is I move one of the radicals. I can either move the square root of 3x plus 1, or I can move the square root of 3x. In this case, I'm going to move the square root of 3x. It's going to be easy to isolate this 3x plus 1 right away, remove that so I don't have to deal with that later. So that means minusing 3x on both sides. So when I minus 3x on both sides, I am left with the square root of 3x plus 1 equals 2 minus the square root of 3x. So now this radical on the left side is isolated. Since it's a square root, I square both sides. And I square the right side also. Square root of 3x plus 1 squared is 3x plus 1 equals, when I square this right side, this again is going to be a perfect square trinomial. So if you have trouble seeing it, then write it out. So it just makes it easier to see. And be able to figure out what we're doing here. So I'll write this out so you can kind of visually see this as I'm working it. So I square the first term, that's 4. Now what I have to do is I'm going to take 2 times a negative square root of 3x. So that's a negative 2 square root of 3x. Doubled is a negative 4 times the square root of 3x. Got that so far? And lastly, square the last term. So a negative times the square root of 3x times itself gives me a plus 3x. Okay, so now at this point, what do? Well, I want to combine like terms. If I possibly can do so, I'm going to do that. All right, so the next step is this. I have a 3x on this left side, and I have a plus 3x on the right side. Well, if I combine those as like terms, they cancel, don't they? Because if I go minus 3x and minus 3x, they'll cancel. It leaves just 1 equals 4 minus 4 times 3x. All right, so let's subtract the 4 from both sides, and I get a negative 3 equals the negative 4 times the square root of 3x. At this point, I can square both sides of the equation. So now I'm going to square both sides of the equation. So I'll square again, because I'm going to remove this other radical on the right side. Negative 3 squared is 9 equals negative 4 squared will be 16 times this 3x, because then if I square the square root of 3x, I have that. On the right side, I have a 16 times 3 that I must work with. So 16 times 3 is 48 times x. Divide both sides by 48, and I have 9 divided by 48 equals x. This can be simplified. I can divide both of those by 3, so that's 3/16. Now, for the end, due to time, I'm already over 8 minutes on this video. So yes, this does work. Please trust me on that. I have tested it in the past, and it does work. You would have 9/16 plus 1, and there's a way you'd have to change that into an improper fraction, and you would do this one into an improper fraction also, and you would get 2 equals 2. This one does work. So what do I want you to do for work? Well, let's see here. There it is. I want you to work on page 456. I want you to do problems 11, 13, 33, 37, 39, 43 to 45, and 47. Please show your work and please check your answers before you turn it in. That way, if you need help with anything, we can look it over together and make some improvements. Let me know how I can help you.